This is the second video intended to work in conjunction with your worksheet on parallel lines versus perpendicular lines. In the last video, we examined the relationships between the equations of two lines that are parallel. In this video, we will discuss the relationship between two lines that are perpendicular. Once again, I'll be doing this in a little bit of a different order than what is on your paper. So please pay close attention to the question numbers next to each part of this video. Let's look at the first example, where we are asked to graph the lines y equals 3x minus 2 and y equals negative 1/3 x plus 1. Please pause the video and graph these two equations. After graphing, this is what your graph should look like. Take a close look at both of these lines. What do you notice about their location and their relationship to each other? You should see right here at this point where they intersect, we have a series of right angles created. Of course, if you remember your vocabulary from the past, whenever two lines intersect and create four right angles, we are dealing with two lines that are perpendicular. Let's take a look at our second set of linear equations. We are given the two equations, y equals negative 2x plus 1 and y equals 1/2 x minus 1. Just like before, please take a moment, pause the video, and graph these two equations. After graphing, it should look something like this. Now, of course, once again, if you examine these two lines, you'll notice that where the two intersect, we once again have a series of right angles created, meaning that these two lines are perpendicular. Just like before, we are going to examine the equations to determine what makes this happen. Now, of course, we know the purpose of the constant in our equation. The constant gives us our y-intercept. The y-intercept is nothing more than tell us where our equation is going to cross the y-axis. So we can actually fill that in right now. That being said, that won't be the part that is going to cause these two lines to become perpendicular. The other part that we have that we can focus on would be our slope. And if we look at our slope, in the equation y equals negative 2x plus 1, we have a slope of negative 2. And in the equation y equals 1/2 x minus 1, we have a slope of 1/2. These two numbers are very interesting. We can take the slope of negative 2, and we can turn this into a fraction. Of course, all of you know at this point, in order to turn an integer into a fraction, we give it a denominator of 1. We look at these two slopes. What do you notice about the denominator of the slope negative 2 over 1? You should see that it's the exact same as the numerator of the slope 1/2. You should also be able to tell that the numerator from our first slope here, the negative 2 over 1, and the denominator from our second slope, the 1 over 2, are actually additive inverses of each other. One is a positive, the other is a negative, and they are the same digit. This is the piece that is going to make our two lines perpendicular. The slopes are the pieces that will make our two lines perpendicular. Specifically, though, our two slopes are going to be negative reciprocals of each other, meaning that if one of the slopes, like in the previous example, is negative 2 over 1, we will flip the slope, we will flip the fraction, make it its reciprocal, and we will give it its opposite sign, leaving us with the example just provided, a slope of 1/2. Let's take a look at this example here. If we are given the equation y equals 4/5 x plus 1, in order to create a line perpendicular, we are once again going to look at our slope. We need an equation that is going to have a negative reciprocal of 4/5. In order to make the reciprocal, we take the fraction and we flip it over. Meaning instead of 4/5, we now have 5/4. And then we negate it. The original slope is a positive, therefore our new slope would be a negative. You can fill the rest of the pieces in and choose a y-intercept. Pause the video for a moment and see if you can come up with two equations of lines that are perpendicular to y equals 4/5 x plus 1. I have provided you with some examples here. You'll notice that in each of my equations, we have a slope of negative 5 over 4, which is the negative reciprocal of our original slope, 4/5. So any equation that you create at this point that is going to be perpendicular to the line y equals 4/5 x plus 1 must have a slope of negative 5 over 4. Take a moment, pause the video, and circle all of the linear equations below that will be perpendicular to the equation, to the line, y equals negative 3x plus 2. Given our original equation here, y equals negative 3x plus 2, let's examine our slope. Our slope in this case is negative 3. But if we want to make this a fraction, we now have negative 3 over 1. Therefore, any line that will be parallel to this will need the negative reciprocal. Thus, we flip our fraction and we give it its opposite sign. The original slope is a negative, therefore the slope for our parallel line will have to be a positive. The only two examples here that follow that rule are y equals 1/3 x plus 1 and y equals 1/3 x minus 9. To sum up both videos, in order for two lines to be parallel, the two lines must have the same slope. And as we examined in this video, for two lines to be perpendicular, the slopes must be negative reciprocals. As stated before, regardless of the slope, the y-intercept tells us where our line is going to cross the y-axis. As always, please feel free to use the comment section in order to have discussions about the slope and the y-intercept and the relationships between two lines and how it affects whether or not lines are perpendicular or parallel. If you have any other further questions, please don't hesitate to ask myself or your other math teachers.